Okay, for our binary compounds, we're going to be following this roadmap. We're going to first ask, is it binary? Namely, are there only two types of elements present? And if we do have a binary compound, we next need to ask, is there a metal present? If a metal is present, we need to determine whether it is either a type 1 metal with only one charge or a type 2 metal with more than one possible charge using the appropriate rules for each. Now, if there is no metal, we are talking about a type 3 binary or a binary covalent compound. And for these type 3 compounds, we are going to be naming them as if they are ionic, though of course they are not. Okay? In this case, we will be naming the first element first, followed by the second element, and naming that second element as if it were an anion, that is, giving it an IDE ending. Now, the complications with type 3 binary are that we again want to have a name that is unambiguous, a name that refers to a single entity. And so we will see that in some cases we are, let me get my thing going here. Okay. We encounter the following types of problems with these type 3 binaries. So there are a variety of compounds that are formed between nitrogen and oxygen. So there's NO, there's NO2, there's N2O, there's N2O3, N2O4, and a variety of others. And so we can't call all of these compounds nitrogen oxide because then we don't know which we're talking about. And so we are going to use prefixes to indicate the relative number of each element, never using mono on the first element if there's only one. And we're familiar with examples of this already. For example, we all know that CO2 is called carbon dioxide. So this is an example of a type 3 binary compound. Now the prefixes that we use, indicate the relative numbers. So for 1, we use mono, 2 di, 3 tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 is nona, and 10 is deca. And we need to be familiar with all of these prefixes, at least 1 to 10. So you are responsible to know these 10 prefixes and what they mean and to use them appropriately. And so when we have a type 3 binary, we need to determine that is a type 3, namely that it is a binary compound and there are no metals present. So in BF3, this falls into this category. So we're going to start by naming the first element first, just as its element name, boron. And we are going to name the second element with an IDE ending, fluoride, and we are going to use prefixes to indicate the relative number of each element. So in this case, we would call BF3 boron trifluoride, right here. Okay, and so we'll do a couple more here. So for NO, we are going to name our two elements and the relative number. So we have 1 nitrogen and 1 oxygen. We name this nitrogen monoxide. Okay. Now if we have N2O, this is a different species. And so there are 2 nitrogens now and a single oxygen. We call this dinitrogen monoxide. Now N2O5, again, nitrogen and oxygen containing compound. We will name this dinitrogen pentoxide. Okay, so that's always going from the formula to the name. So if we have a compound like sulfur hexafluoride, seeing that hexa indicates that this is a binary type 3 compound, and we're going to write the first element first in the formula, sulfur, then fluoride is F, and then there are 6 of them. So sulfur hexafluoride has a formula of SF6. We only use these prefixes with these type 3 binary compounds. We never use Roman numerals, and there are no ions in these compounds. So these rules are specific to type 3 binary compounds.